I'm trying to clean the shop up a little bit, and I bought some shelving. Trying to get that stuff off the floor and into some sort of manageable situation. And in doing so, it's like an archaeological dig. Some of those 3-ring notebooks that are standing right up there have been sitting around the shop in various places for 20 years. As I was leafing through one of the 3-ring binders, this unbuilt kit fell out. As near as I can make out, I bought this in 2013 maybe, from Jackson Harbor Press kit sales. There is a Jackson Harbor Press that I guess is a print house. In any event, it's a low frequency converter kit. I looked it up and it's still available, so although I found some other kits unbuilt kicking around, they're no longer supported by anybody. But this is still available, and so I thought I'd show it to you. I downloaded and printed out the construction manual. It's pretty straightforward. In the back few pages of the construction manual, there is a bunch of pages on modification ideas. Various things that can be done to change, maybe improve the kit. And these ideas go on for page after page. The kit was also discussed on the web. The kit was discussed by this fellow. I didn't print out the whole article, but he talks about building it and operating it. And this site, which is now defunct, was at one time really a nice site. It's a shame it's not still working. Did a big discussion on the low frequency converter. There's like 12 pages here. Now the link to this guy's site, of course here it is, but the link to this site is contained in the directory down below. I took the entire HTML document pertaining to the Jackson Press converter and saved it intact to my site down below. I hope I didn't infringe on Jack Smith's rights. There's information to be found, as well as the seller's information. A link to the seller's page, that is, in the attached link. There is another YouTube video on this kit, although the video presenter in that case does not mention Jackson Harbor. In fact, he's covered up this information. I have a link to that YouTube video down below. What we have is a power supply. That's nothing outstanding. The heart of this is this oscillator mixer. The 620 chip itself supports an oscillator, and that's right here, a crystal oscillator. So it's a mixer. One of its inputs is from the crystal oscillator. Its other input is taken through this low-pass filter. This low-pass filter is designed to cut off at 300 kilohertz. Anything above 300 kilohertz, theoretically, does not appear in the mixer. This gives us a bandwidth from some very low frequency up to 300 kilohertz. The output products from the mixer are buffered and sent out to a communications receiver. So what we have is a low frequency converter that covers the spectrum of, say, 10 to 300 kilohertz that provides an up conversion to take this frequency band and raise it by this crystal oscillator value. So functionally it looks like this. Anything between 10 kilohertz and 300 kilohertz is presented to the mixer input, as well as whatever frequency crystal oscillator is included in the kit. The output from the mixer contains this information, the sum of these two, and the difference of these two. Well, forgetting about this information appearing in the output, let's look at these three things. First of all, the 4 megahertz oscillator signal appears here in the output. Then the sum of these two appears here. And then the difference appears here. Now, this is convenient, especially with the 4 megahertz crystal. If I hook a communications receiver up to the output and I tune it between 4 and 4.3 megahertz, I will get, if I neglect the 4, these frequencies here and here. Anything inside this frequency appears inside of it here. And all I have to do is ignore the leading number. In my case, it's a 4, because I'll be using a 4 megahertz oscillator. There are some communications receivers that are designed to receive ham bands only. This span from 4 to 4.3 megahertz is not in the amateur bands. This frequency span is in the 80 meter amateur band. The problem is I can't just drop the first digit and read the dial directly. A 10 kilohertz signal heterodyned up will be 3.990. A 300 kilohertz signal heterodyned up will be 3.7 megahertz. Because the span is reversed, the span is in this direction from 10 to 300. It's traveling in this direction from 10 to 300, offset by the 4 megahertz oscillator. So if you have a general purpose communications receiver, this works well. If you have an amateur only receiver, you have to do the math because the span is inverted. So looking at the components in this bag, There were some changes made over the years to this kit. And there's notes here that cover the changes that have been made. And then there's another, well, this is the circuit board for the kit. I believe this bag of parts modifies this low-pass filter to extend the bandpass up to 500 kilohertz. I believe I'm going to just defer building this at the time being. Apparently over the life of the kit from at least 2008, they've changed these coils. Here's what's currently used. They apparently used at one time an FT37, then they used a binocular type of core, and then they used an FT3761. And this is called the original, the second, the third, and the current. I believe these cores to be the FT3761. We can rule out this because it's pre-wound. This 3743, 7 inches of wire used to make 8 wraps. This current ballon, 8 inches of wire to make 9 wraps. It looks like I'm going to have to make 22 turns using 15 inches of wire. Well, that sort of makes sense. Let's unwrap this and see if we have 30 inches. And looking at this, we have 31 inches. So I'm going to go with 22 turns. I'm going to cut the wire in half and assume this is what we are talking about.